In this video, I am going to find the area between two functions, and these two functions are your familiar sine and cosine functions, the trig functions, and we'd like to find the area between 0 and pi over 2 for these two functions. Okay, so let's say we are going to put absolute value sign, sine of x minus cosine of x dx. There is a reason for putting the absolute value sign, because the functions are not always bigger than one function is not always bigger than another in the interval we are considering. So that's why I put the absolute value sign, but I'm gonna break it down into simpler pieces so that you can see. Our original formula was this, right? Integral a to b f of x minus g of x dx. So here we make the assumption that f is greater than or equal to g on the interval, closed interval a comma b, and f and g are continuous on ab. But for this function, obviously you can see right here cosine is bigger than sine, and right here the sine is bigger than cosine. So what we need to do, the way we get rid of this problem, is just that we break it into two pieces. So let's call this my area 1. So the left one, this is my area 1, and let's call this one my area 2. So finding the integral from 0 to pi over 2 for absolute value of sine x minus cosine of x is going to be equivalent to finding the integral from 0 to pi over 4. Remember, they meet at pi over 4, because at pi over 4 sine pi over 4 is square root of 2 over 2, and cosine pi over 2 is square root of 2 over 2. Now we are going to find the area 1. So area 1 is going to be integral 0 to pi over 4 cosine of x is bigger here minus sine of x dx. And then we are going to find the area 2 where cosine and sine are going to switch places. So let's find the area 1, which is going to be integral of cosine of x is sine of x, and integral of sine of x is negative cosine of x. So negative and negative is going to make it positive. So you're going to have cosine of x, this evaluated from 0 to pi over 4. So that's going to be at pi over 4. Sine pi over 4 is square root of 2 over 2, and cosine pi over 4 is square root of 2 over 2, minus sine 0 is 0, and cosine 0 is negative 1. So that's going to give me 2 times square root of 2 over 2 minus 1, which is going to be 2 and 2 going to cancel out, right? Is going to be equal to square root of 2 minus 1. So we are going to keep this number in mind. Now let's go ahead and find the area 2, which is going to be a2. Again, the integral is the same, but the limits of integration is different. So integral pi over 4 goes to pi over 2. This time, however, sine is bigger than cosine, so we are going to switch. So sine of x minus cosine of x dx. If I integrate it, is going to be negative integral of sine of x is negative cosine of x minus integral of cosine of x is negative cosine of x is sine of x, and I need to evaluate it from pi over 4 to pi over 2. So if I do that, at pi over 2, cosine of pi over 2 is 0. So it's going to be 0 minus sine of pi over 2, by the way, is 1. Then minus negative, and this negative is going to make it positive. Cosine of pi over 4 is going to be square root of 2 over 2. Then again minus, and this minus subtracting, right, is going to give me positive square root of 2 over 2. That gives me square root of 2 minus 1, I guess. So it's the same area. So total area is going to be A is equal to A1 plus A2, which is nothing but 2 times square root of 2 minus 1, which is nothing but 2 times square root of 2 minus 2. So when you have a function, by the way, where the interval of integration or interval where you are trying to find the difference between the functions, they switches, that means they are not exactly like this. So our assumption that our integration would work if f is always greater than g, right? G of x, right? But if that is not the case, then you have to break it down into pieces. Like this is true here, but for this particular example, it is not true. The interval over which we are integrating 0 to pi over 2, left half, the cosine is bigger, right half, the sine is bigger. So you have to bring it, you have to divide it into two pieces and integrate over each of these intervals, or integrate over these two regions of interest. And I hope that this discussion was helpful. Thank you very much.